So in the previous problem, we were talking about exponential growth, and we know for exponential growth, it comes in two forms, right? Well, it comes in one form, and it basically looks like this, where it goes up forever and ever and ever and ever, right? You know, in real life, a lot of things doesn't follow that model. After a while, things stops growing, right? It slows down and eventually stops. It just levels off at a particular range. Right. And that type of function we call a limited growth function or a logistic growth function. And that type of an equation is given by, that looks something like this, where P of t, which is some future amount, is equal to the limiting number over 1 plus c e to the negative lkt. Now the good news is they're going to give you this function, so you don't ever have to worry about, you know, coming up with this. But this is a general format for that function, just like we know for the exponential function, y is equal to c e to the kt. This is a general format for the exponential function. This is a general format for the logistic growth function. And here's a graph of that. This is how it looks. See, we start out at some particular value in the very beginning. Then we grow. And after a while, it just gets to a point where it stops growing. Do you guys know anything that can be modeled by this type of function that you think would look like this? X to the third. Not exactly. X to the third looks a little different. But that's a good, X to the third fate kind of looks like this. Right? So kind of similar, but I'm thinking, some real life scenario that's modeled by this, right? Up here for exponential growth, we're looking at money, investment, we're looking at artwork, stuff that, grows exponentially over time. Global population, Cameron. So what's going to limit the global population, Cameron? Wait. Cameron? Things like COVID. But you're right. And it's not just COVID, right? This is this occurs a lot of biological applications. Resources like what? Like food, shelter, right? That's going to limit population growth. Right, so initially population will grow to water, that's true too, right? So Earth, cannot keep growing exponentially because we don't have enough food supply, we don't have enough water supply, we don't have enough land space. I mean, here in Florida, we're building just about every corner you can think of. Fortunately, we won't run out of land, in our lifetime. but it's ridiculous. But this is what it looks like. And you only have actually questions on the homework. Build up, that's a good idea. And people are actually doing that, you know, Faith, Alfred. Along the intercoastal, all of the one-story single-family homes that are still there, you know, they're buying those land and bulldozing them and building high-rise there. So they're building up on that space. I read an article recently that talked about the value of the air. And it's really above the airspace above a house because you can build up, just like Alfred is saying. But that's a whole new lesson in itself. All right, let's look at this question. In downtown Lake Worth, I think that's downturn all over the place. All right, let's look at his questions. Suppose that a company introduced a new computer game in a city using television ads. X ads are broadcasted satisfying the equation below. Complete part A through D. So here they're giving us an equation for I think this is a sale. They didn't. So it's a percentage of the odds. So P of X here. Let's put it in here. Percent of audience that buys game. So they came up with a formula for determine the percentage of, you know, the population that's going to buy this game based on the television advertisement. All right, so the first part of this question is what percentage would buy the game without seeing a TV ad? All right, and we know we have people like that, right? We hear that a new iPhone is coming out, we're gonna buy it. We don't even need to see the ad. Are there people like that? Samira, you're like that? Not me. My next iPhone is probably going to be a 10. I don't need all the bells and whistles. Plus, I get the bigger depreciation in costs. So you can go pay your 10. Yes, 10. I have 10 something. I don't care. As long as I can talk on it. All right, so what are we going to do here for part A? Just replace x is equal to 0, right? So for part A, let's just stick it up here since we can see this. P of 0 is equal to 100 over 1 plus 50 e to the negative 0.11 times 0. So what do we get for this? Then I want to get a value for this. 1.9607. 1.9. So 2% approximately, I said to round to 1 decimal place, around to the nearest tenth. So 2.0% of the population would buy it without even seeing a single ad. All right, let's about part B. What percentage buy the game after the ad is run 16 times? So, not allowing me to copy this. Like we just have to write it. P of x is equal to 100 over 1 plus 50 e to the negative 0.11.
Did you deal with 100 divided by 1.50 to e to the 0 to get the 2.2% or the 2% whatever you got?
I didn't get that, but yeah, that's all they did. They plug in 100 divided by all of this. Now be careful how you enter it in your calculator, right? Because that might.
When I put it in my calculator, I get 66.6666666667.
You get 56. Make sure when you put the parentheses around this piece on the bottom.
Okay.
So put a 100 divided by, put a parentheses, because that shows you're dividing by everything on the bottom.
Okay. Do it
So
again.
tell me if you get anything different. So what do we get for this? What's the answer after 16 times? 10.41%. That's it. How about 100 times? Can someone calculate that? When x is equal to 100.
It's 99.9%.
99. So if they run that 100 times, they will probably get most of the population to buy this program, right? How about if they run it 150 times?
$99.99.
99.99. This was 99.2. So it went up 0.07, percent by running the ad 50 more times. Do you think the company who is selling this product would run it 50 more times just to get 0.07% increase in sales? They probably would not, right? It doesn't make sense to run it 50 more times just to get an increase of 0.07% in sales. It's not cost effective. All right, find the rate of change of P or P prime of X. So once again, P of X is equal to 100 over 1 plus 50 e to the negative 0.11x. How do we find P of X or P prime? Unfortunately, there is no shortcut for this. Which rule are we using?
Quotient rule.
The quotient rule. Very good. So this is our numerator, and this is our denominator. And if you remember, the quotient rule says what? It's a denominator times the derivative of the numerator minus the numerator times the derivative of the denominator over the denominator squared. So our denominator is actually 1 plus 50 e to the negative 0.11x times the derivative of the numerator. And what's the derivative of the numerator?
0.
0. Very good. Minus the numerator, which is 100, times the derivative of the denominator. So what's the derivative of 1 plus 50 e to the negative 0.11x? Oh, what's the derivative of the 1 to start with? 0. So now we're just left with finding the derivative of this. And if you remember, the derivative of the exponential function is 50 e to the negative 0.11x times the derivative of the exponent, which is negative 0.11. So that's the top piece. Now we're going to take the denominator, which is 1 plus, sorry, 50 e to the negative 0.11x, and we're going to square that. So that's a derivative. Probably want to simplify that. All of this piece is going to cancel out because it's times 0. The negative times the negative here will make it a positive, and 100 times 0.11 would become 11. So this would be 11 times 50 e to the negative 0.11x all over 1 plus 50 e to the negative 0.11x all squared. Faith, where is that 0.11 you're talking about?
Were you talking the 11 that you put in the front? That's the 0.11, right? Or where'd you get that 11 from?
Well, because we're left with this 100 here and the 0.11.
Oh,
So when we multiply those two, it became 11.
would it be the same thing if you just wrote down the derivative of? Were you supposed to like find the derivative of that instead of just putting 50e to whatever times 0.11?
Say that again. Take the derivative of what?
So instead of you breaking it down like the 50e to the negative 0.11x times negative 0.11, if I just wrote down the derivative, do I have to break it down like that, or can I just write down the derivative of that?
But that's the derivative of that.
Because
What?
I did 0.11 times 5. I mean times 50.
Okay, you just write it in the front. It doesn't matter if you put it in the front or back. It's still going to come out to be the same.
Okay, thank you.
Because in the end, because look, we still haven't even finished this, because we're still going to multiply the 11 and the 50, because we can do that. Right? Which is what? 5,500 e to the negative 0.11x all over 1 plus 50 e to the negative 0.11x all squared. So this would be like our final answer. So this, in math, it doesn't matter which order you put the numbers when you're multiplying them, you're still going to end up with the same answer. So if it's in the front or in the back, it's still the same thing. All right, what was part D of this question? Sketch the graph. Okay, well, here's the graph. We kind of understand that. So the graph looks like this. Based on the numbers that we got here, right, at 0 time, it was like a 2%, we said. Right? Did we get that somewhere here? So at 0 time is at 2%. Well, not 0 time, but 0 adds. At 16 adds, we had 10.4%. So this would be 10, 20. So it's here. At 16 add would be at 10.4. And you see, up here is what we're talking about. At 100 adds, it's like it's leveling out. It doesn't even make sense. It doesn't go higher because the percentage of people who buy the product can never be more than 100%. So after a while, it's probably, you probably want to do advertisements up to maybe about here, because after that, it just slows down. Does that make sense to everyone?